Alright guys, so this the second episode of our videos, and we'll be treating question number 1, and we have integral of ln x over x dx, and we are making this is an integral by u substitution. So we make u equals to ln x. Now when we say u substitution is not necessarily that you make u your substitution. You can decide to make p your substitution, z your substitution, right? So when you differentiate u with respect to x, you have, when you differentiate ln x, you have 1 over x, and at the end of the day we have our integral to be, now when you integrate sine u, you are going to have minus cos u, so kindly correct that part. So we have minus cos u plus c, and don't forget that u is equals to ln x. So our final answer is going to be minus cos ln x plus c. So this is the first question, episode 1. Now we move down to question number 2. Have question 2, we have integral of sine square root of x over x. Now whenever you come across integrals like this, the best method to use integrals of this nature, the best thing to use is you use whatever that is in the numerator as the substitution. So we let u to be square root of x, and when you differentiate square root of x, you have 1 over 2 root x. So this one is from basic derivative, right? Now when you substitute the value for the x back to the integral, we have our new integral to be integral of 2 sine u, and when you integrate sine u, you have minus 2 cos u plus c, and you put the value for u back there, and we have our final answer. So on to question number 3. So we have question number 3, and it is an integral on trigonometric functions, two different trigonometric functions. So we have integral of tan cube x sec squared x. Now this is also a good example of integral by u substitution, and we let u to be equals to tan s, such that when you differentiate u with respect to s, you have sec squared x, and when you substitute the value for x back, we have tan cube x, right? And don't forget that u is equals to tan cube x. Now when you differentiate u raised to power 3, you have u raised to power 4 over 4 plus c, and you substitute back the value for u, and our final answer is tan x all raised to power 4 divided by 4 plus c. So down to question number 4. Okay, so question number 4, we have integral of x squared, x plus 1 over x squared plus 9. So what we do in this integral is we split the integral into two parts. You split it into x over x squared plus 9 and 1 over x squared plus 9. Now the first integral, you'll be using u substitution for the first integral, while the second integral is a trigonometric integral. So we have an automatic answer for that one. So the answer for that one is tan inverse of x over 3. Since you recall that tan inverse of x over a is the same thing as integral of 1 over x squared plus a squared. So when we use u substitution for the first integral, we have our u to be x squared plus 9 and the u to be 2x dx. So when you do the necessary cancellation and you insert the value for the s back to the initial integral, you have 1 over 2 integral of 1 over u, and when you integrate 1 over u, that's ln u, and you substitute back the value of u to be x squared plus 9. So we have our final answer to be 1 over 2 ln, don't forget this is an absolute value, so it is different from a bracket. So when you are writing your final answer, you have ln absolute value of x squared plus 9 plus tan inverse of x over 3 plus c. So that's for question number 4. So we have the last question, which is question number 5. So this is the last question for this episode. We have integral of 1 over square root of 3 minus 2x minus x squared. Now, you notice that there's no way we can split this integral rather than using completing the squared method. So we have x plus 1 all squared minus 4. So when you use your completing the squared method to simplify the denominator, we can now use the special trigonometric function formula to write our final answer. So therefore our final answer becomes sine inverse. This is a special integral, so it is sine inverse of x plus 1 over 2 plus c. So this is the last question for this episode. Thank you.